So see here, an excellent reagent for converting a primary alcohol to an aldehyde is the pyridinium chlorochromate, which is also called as the PCC. Okay, so what is this PCC? It is a pyridinium chlorochromate, which is an excellent reagent for converting the primary alcohols to aldehydes. Okay, so remember, the primary alcohols can convert into the aldehydes. So when this PCC is present like a catalyst, or the secondary alcohols, they can also convert into the ketones with the help of PCC. So all these reactions are nothing but the oxidation. So primary alcohol, it is oxidized to aldehyde, or secondary alcohols, it is oxidized to ketones. So this PCC will be acting like a good oxidizing agent. Okay. Actually, it's not a very strong oxidizing agent, but it is a mild oxidizing agent. Remember. Okay. So in order to oxidize the alcohols, if you oxidize the primary alcohols, they will convert into aldehydes in the presence of this PCC. Remember this. So in the presence of this PCC, they will convert the primary alcohol to the aldehydes, or secondary alcohols, they will be converted into the ketones when there is a pyridinium chlorochromate is present. Clear? So this acts like a mild oxidizing agent. Okay. So why we are calling it as a mild oxidizing agent? First, suppose what happens if it is a strong oxidizing agent? Okay. See, alcohols, they are converted into aldehydes. That's okay. But these aldehydes, they can further convert into carboxylic acid. But as it is only the mild oxidizing agent, so the reaction will stop only here. It will not, further conversion will not happen. Further oxidation will not happen. If it is a strong oxidizing agent, whatever the aldehydes are there, they will be further converted into the carboxylic acids. Okay. So remember this. So mild oxidizing agent, so the reaction will stop. Reaction will stop at aldehydes, or you can say aldehydes formation. But if you are using the strong oxidizing agent, so if you use strong oxidizing agent, then whatever the aldehydes are there, those aldehydes will further turn into carboxylic acids. So you can say here, in the presence of strong oxidizing agent, so oxidize into carboxylic acids. So is it clear? So tell me, what is this PCC? It is a pyridinium chlorochromate. What does it do? It acts like a mild oxidizing agent. So what is this mild oxidizing agent? It converts the primary alcohols to aldehydes, secondary alcohols to ketones. So apart from that, if we use the strong oxidizing agent, the aldehydes will further oxidize to the carboxylic acids. Okay, but as it is not a very strong oxidizing agent, so that will not happen. So is it clear? So only this
Yes,
conversion, the
sir.
aldehydes to carboxylic acid, will only happen if you are using the stronger oxidizing agents. If you don't use, if you just use this pyridinium chlorochromate, it will not happen further. The reaction will not happen. Is it clear, guys? Mandara?
Yes, sir. Yes, sir.
Yes,
So
sir.
just remember, this is the structure for the pyridinium chlorochromate. Okay. So how do we make this pyridinium chlorochromate? So this can be done by forming the chromium trioxide dissolved in the HCl. Okay. So see here, this can be prepared when CrO3. What is meaning of CrO3? Chromium trioxide reacts with a HCl and reacts with a pyridine. So there's a lone pair on the nitrogen. Okay, so it will give the reaction like okay. So this is called as the pyridinium chlorochromate. So just remember these names. So what is this CrO3 is called? The chromium trioxide. And what is this? What is this? It is nothing but the pyridine. Okay. So when you, okay, the PCC, that is pyridinium chlorochromate, it is formed when the chromium trioxide is dissolved in the hydrochloric acid and then treated with the pyridine. Then you will be getting this PCC, pyridinium chlorochromate. Understood? So how does the pyridinium chlorochromate is formed? You need to treat the chromium trioxide with a hydrochloric acid and you treat with this pyridine. So you finally get this pyridinium chlorochromate. Clear?
Yes, sir.
So PCC when dissolved in methylene chloride, CH2Cl2 will oxidize a primary alcohol to an aldehyde and stop at the stage. I told you why? Why it will stop only by formation of the aldehydes? Because it is not a strong oxidizing agent. It is only the mild oxidizing agent. For suppose you take a primary alcohol. What is meaning of primary alcohol? The functional group is attached to carbon, which is attached to only single carbon. Okay. So if you see here, this is CS3, CS2, OH. So whatever this OH, it is the functional group that is attached to the carbon, which is attached to only one carbon. So this carbon is the primary carbon. So this primary alcohol in the presence of PCC and CH2Cl2. Okay. So that is methylene chloride. It will oxidize to form the aldehydes. So what is aldehyde? C double bond OH, or you can say CHO is nothing but the aldehyde. Okay, remember this. So this is nothing but aldehyde. Is it clear? How does this happen?
Yes, sir.
Okay. So PCC will oxidize a secondary alcohol to ketone. I also told you. Okay. So the primary alcohol will turn into aldehyde. The secondary alcohol will turn into ketone. So you take a secondary alcohol. That means a carbon which is having the functional group OH alcohol. It is attached to two different carbons. Then we call it as the secondary alcohol. Okay. So this is the functional group OH that is attached to the carbon. This carbon is attached to two different carbons. So we call it as the secondary alcohol. Okay. So remember this. So this is a secondary alcohol. So this secondary alcohol in the presence of PCC at CH2Cl2, it will give the ketones. Remember. Okay. So what is ketone? Ketone is nothing but RC double bond OR. So this structure, if something is having C double bond O and on the either sides it is attached with the alkyl groups, then we call it as the ketone. So this will be the structure. Okay. So this is a ketone. So remember guys, if it is a primary alcohol, it will give the aldehyde. If it is a secondary alcohol, it will give the ketone when there is a PCC is present. So what is name of PCC? What is the name for PCC?
Pyridium chlorochromate.
Pyridium chlorochromate. Okay, remember this. Pyridinium chlorochromate. Okay. So far clear? Any doubts?
No, sir.
Okay. Now this question will be answered by the Mandara. Mandara, tell me, what is the answer? Very simple one. So in presence of PCC, what will be the reaction happens?
No.
Hmm?
Is it gonna be like CH3CH, CH2O?
Finally, what it will form? Tell me that. What is
Ketone.
this? Tell me what is this? Is it a primary or secondary? Tell me this.
Primary.
Ah, primary kada. So primary, right? So if it is primary, how does it will form ketone? So tell me what it will form.
Aldehydes.
Aldehydes. Okay. So it will form like this. CH3, CH double bond, CH, HC. Your wish, you can write anything. In order to show the double bond, I'm writing this way. Okay. Oh. And this oxygen will be having lone pair of electrons. Okay. Or you can write like this if you want, if you're confusing. So this is the aldehyde. Okay. So now tell me, if you notice here, one thing has happened. So when there is a PCC is present, it didn't do anything to the double bond. We know when there is a double bond is present, oxidation mostly happens at the time of double bond. Okay. So here double bond is not disturbed at all. What is disturbed here? The OH group is disturbed, but the double bond is present like intact. Nothing happened to the double bond. So that thing you need to notice. Okay. So PCC doesn't attack double bonds. Remember this thing. Okay. So the PCC will not attack the double bonds. So the double bonds will remain intact. Only the hydroxyl group will be transformed. Okay. How it is transformed? It is transformed into the carbonyl group. What is meaning of carbonyl group? Tell me what is meaning of carbonyl group? Whenever you see C double bond O, that is called as the carbonyl group. Come on, guys, this is very basic things. So what
Sir,
is
isn't
carbonyl group?
C double bond a ketone?
No, 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 no. See, I'm just saying C double bond O. This attachment is called carbonyl group. This attachment can be present anywhere. For suppose C double bond O and it is present like this. This is carboxylic acid. If it is present like R and R, this is ketone. If it is present like this, aldehyde. So whatever the C double bond O, this thing is called as the carbonyl group. Understood?
Yes.
Nitya, whatever I said, you is it clear? I mean, why I'm not saying it's as a ketone?
Yes, sir, it's clear.
Yeah. So just remember the attachment of the carbon with oxygen with double bond, that we are calling it as carbonyl group. I'm not taking this entire thing. I'm just only taking the carbon and oxygen. And I'm saying this as a carbonyl group. So in order to say, for suppose here it is called as hydroxyl group. The hydroxyl group, it is oxidized and turned into the carbonyl group. That is what I mean to say. Okay. So what's happening here? The double bond remains intact. They are not disturbed because PCC doesn't attack the double bonds. It only attacks the hydroxyl group. Whatever the hydroxyl group OH is there, that will turn into the carbonyl group. Understood? And result in formation of which kind of aldehyde is this? Saturated or unsaturated? Tell me, guys, what is this? There's a double bond is present. So can we call this as a saturated aldehyde?
Unsaturated.
Yeah. So this will result in formation of unsaturated aldehyde. Remember. Okay. So that another thing you need to remember, it is unsaturated aldehyde. One more thing. So whatever the hydroxyl group is there, it is attacked by the PCC and it will turn out to be the carbonyl group. or you can say oxidize it into carbonyl group with the help of the PCC. So is these 3 points are clear?
Yes, sir.
Okay. So see here, next one. So oxidation of primary alcohols to carboxylic acids. Okay. So the primary alcohols can be oxidized to carboxylic acid by potassium permanganate. I told you, if you are only having the mild, then it will turn out to be aldehydes. But if you are having the strong oxidizing group, then it will turn out to be carboxylic acids. Here, KMNO4 or chromic acid, they acts like a strong oxidizing agent. Remember this thing. Okay. So you take an alcohol RCH2OH. So this is an alcohol. Okay. So in presence of KMNO4, that is potassium permanganate, or in presence of H2CrO4, that is chromic acid. So in presence of either the potassium permanganate or or H2CrO4, that is chromic acid, it will turn out to be RC double bond OOH, which is nothing but RCOOH, which is a carboxylic acid. So alcohol is turned out to be carboxylic acid in presence of KMNO4 or chromic acid. Both are acting like a strong oxidizing agent. If you are having only mild oxidizing agent, this primary alcohol will turn out to be the aldehyde. If it is a secondary alcohol, it turns out to be the ketone. But if you are having this strong oxidizing agent, it will turn out to be the carboxylic acid. This thing you should remember. Okay. So next one, the reaction with KMNO4 usually carried out in the basic aqueous solution. So from which MnO2 precipitates as the oxidization takes place. For suppose, so whatever this reaction is there, I directly told you how the product is formed, but actually it will form an intermediate stage. For suppose you take this R carbon OH. This is an alcohol. So in presence of KMNO4, guys, please write with me. Okay. So you take the water molecule. So that's why it is said the basic aqueous solution. That means from the water molecule, you are getting the hydroxyl groups. So that's why it is called as basic. So if it is, remember, whenever in the reaction, if you see H plus, then we call it as the acidic medium. If you see OH minus in the reaction, then we call it as the basic medium. Okay. Or you can say the basic solution. Remember, here I represented OH minus because to show off it is a basic solution. If I put H plus, that means it is an acidic solution. And I need to eat the reaction. 1 second, I need to put charging. Okay. So KMNO4 OH minus. So that will be giving me R C double bond O minus K plus. I'll tell you what is this. Okay. So this is an intermediate stage. Remember, whatever the ion it is formed, we call this as a carboxylate ion, which is an intermediate stage. Okay. And this will further react with H3O plus and finally it will give, and you will be getting MnO2 as well. Okay. So it is precipitated. Whenever you precipitate, put the arrow down. So what are the things you need to observe here? Okay. So first of all, what's happening here? There is a strong oxidizing agent you are using. Okay. And this strong oxidizing agent you are doing in the basic condition. Remember this. So it is happening in the basic condition. Okay. So you are using a strong oxidizing agent. Strong oxidizing agent in basic condition, or you can say in basic solution. Understood? So here, what is the strong oxidizing agent? The potassium permanganate, which you are using in the basic condition. Okay, that will be oxidized to carboxylate ion. Remember this. So what is the name of this compound? It is a carbo. It is a carboxylate ion, which is an intermediate stress. So now this carboxylate ion, you are treating with the acidic ion, acidic medium. So what is this H3O plus? Nothing but H2O plus H plus. So it will give the protons. So as it is a proton donor, this will act like an acidic medium that you need to remember here. Okay. So this is an acidic medium or acidic solution. So when you treat with an acidic medium, that will convert the carboxylate ion into the carboxylic acid, which is finally you will be getting the carboxylic acid. So this is carboxylic acid. So understood how the reaction has happened? Is it clear or any doubts? So what is this? This is an alcohol. Which type of alcohol? The primary alcohol. That is another important thing you need to notice. So I'm repeating again, remember. So what's happening here? There is an oxidation of primary alcohols for happening. Okay. How we are doing this oxidation of primary alcohol using a strong oxidizing agent called as the potassium permanganate. Okay. So this potassium permanganate, you are using it in the basic solution and you are eating this reaction. Okay. So you can also call this as aqueous basic solution because there's a water is also present. Okay, so when you do this, you will be getting an intermediate ion or oxidized ion, which is called as the carboxylate ion. Okay, which is nothing but RCOO minus K plus. This is RCOO minus K plus. This is RCOH, which is an alcohol. So now you treat with an acidic medium that will convert the carboxylate ion into the carboxylic acid. Okay, so which will turn out to be RCOOH. Understood? Apart from this, the MnO2, that is, what is MnO2 called? Come on, tell me, what is MnO2?
Manganese oxide.
Hmm? Is my
Magnesium
voice
dioxide.
audible or is it breaking?
No, sir, it's audible.
Okay. So what is this MnO2 called?
Magnesium dioxide.
Manganese
Magnesium.
oxide.
Okay. Then what is this
Sorry, sorry,
Mg?
the
It is
manganese.
manganese, right?
I mean, no, no, no. It's just like in my mind it was manganese and I'm mispronouncing it as magnesium.
What is this called? Manganese dioxide. Okay. So Mg means magnesium, Mn means manganese. So this is a manganese dioxide. So is it clear? So what happened in this slide? Any doubts?
No.
Okay. Nitya, your voice is breaking.
So now is it fine?
You are having the robotic voice. Great. Okay. So do this question. So an oxidizing ethanol using a strong oxidizing agent, carboxylic acid is obtained. So which of the following statements is correct regarding the formed carboxylic acids? So tell me. What is the option? So first of all, let's tell me the reaction. What is meaning of ethanol? What is ethanol? Which functional group ethanol means? Come on, tell me what is meaning of ethanol? Which functional group ethanol means? Array, you are in second year, 12th. Ethanol means, what is ethanol? Wow. Nitya, do you know or you don't know?
I don't remember, sir.
Hmm?
I don't remember, sir.
What is there to remember? When we use Al, if it is ethanol, what is this ethanol means? CH3, CH2, OH. For what we will use Al? This is for alcohol. Al is for aldehyde. Remember, ethanol, it's an aldehyde. Whenever you use the suffix Al, it is an aldehyde. So nothing but CH3, same like this. C. But here not CH2 because we know ethanol will contain double bond O and hydrogen will be attached. So this is ethanol. Simple thing. Remember, you should not confuse with these basic things. So see here, how does the reaction will happen? So there is an ethanol that is CH3 C double bond O H, which is nothing but an ethanol. This ethanol, what's happening here? What he said? Oxidized and turned into a carboxylic acid. Okay, so this will be oxidized. So put O within the brackets. That means it will represent oxidized. Oxidation. And this will be giving CH3C. Can I get another carbon here? I don't have a chance to get another carbon. So I'll put O. And whatever this H is there, I will remove the H and I will put the OH. That turns out to be CH3COOH, which is nothing but carboxylic acid. As there are two carbons are there, we call it as ethanoic acid. Remember, whenever you see the word oic acid, it's nothing but carboxylic acid. So two carbons with a oic acid, that's nothing but carboxylic acid. Okay, so ethanol is turned out to be ethanoic acid. Okay, and this reaction is nothing but oxidation process, we can call it as. Oxidation, it's happening in presence of strong oxidizing agent. Remember this. Okay, so what is the question he is asking? Which of the following statement is correct? Now tell me, I told you the reaction. You can see here the reaction. So answer this question. Come on, guys. What is there to think? The answer is very clear. What is the option? Nitya, your voice is breaking. Mandara, you tell me what is the option? Guys, please tell me, am I audible?
Yes, sir.
Yes, sir.
So tell me what is the answer?
So C.
It's the option is C. Okay, so if you see here, how many carbons are present in the ethanol? Two carbons are present. How many carbons are present here? Two carbons are present. So that's the reason both are called as eth and eth. So that is very, very important. You should notice here. Okay, so remember the number of carbon atoms remains same during the oxidation process for conversion of the carbon, that means ethanol, to ethanoic acid. So the answer will be C. Number of carbon atoms formed in carboxylic acid will be same as the aldehydes. Okay. Next one. So oxidation of alcohols. Okay. So far I told you about the primary alcohol when they are converting in presence of strong oxidizing agent. So first what we discussed, the primary alcohol, secondary alcohol conversions in the presence of mild oxidizing agent that we done. So it will give the aldehydes and ketones. And then we discussed about the primary alcohol conversion in the presence of strong oxidizing agent. Now we'll be seeing the secondary alcohol conversion in presence of strong oxidizing agent. Okay, so what will happen here? Secondary alcohol can be oxidized to ketones using the oxidizing agents like KMnO4, H2CrO4. Even if you use the strong oxidizing agents, the secondary alcohols will only turn to ketone. Even if you use the mild oxidizing agent, the secondary alcohol will turn into ketone. That you think need to remember. So what happens in this? The reaction involves converting the hydroxyl group into a carbonyl group. So I told you. So let's take the alcohol. So there's alcohol with OH and there is other R. So there is a two different groups are attached to this carbon. So we can call this as a secondary carbon. Now this secondary carbon in presence of K2, KMnO4 or H2CrO4, it will turn out to be a ketone. So what is ketone? It's nothing but RC double bond OR. So this is called the ketone. So what is the difference between alcohol and ketone? Alcohol is having OH, whereas the ketone, it is having double bond O. So this is ketone. This is secondary alcohol. This is strong oxidizing agent. Understood? So what is KMnO4 is called as? What's the name for KMnO4?
Potassium permanganate.
Only Nitya is answering. What about the others? Potassium permanganate. And what is H2CrO4? Sharon, you say, what is this answer? H2CrO4, what is it called as? Sharon,
Yes, sir.
what is the answer? Do you know or you don't know? Mandara, you say, what is the answer?
Chromic acid, sir.
What happened, Sharon? You are not writing?
Writing, sir.
Okay. So remember, can this, it is just turned the secondary alcohol into ketone, but it couldn't convert further into the carboxylic acid. Whereas if you take the primary alcohol, you treat with the strong oxidizing agent, it converted into the carboxylic acid. Whereas here, the secondary alcohol, the same treatment you have given, but it is only turned up to the ketone, but it didn't further turn into the carboxylic acid. So the question is, can ketone also be converted into the carboxylic acid? Okay. So see here, oxidation of secondary alcohol usually stops at the ketone, even if you use the strong oxidizing agent or mild oxidizing agent. Why? Whatever, in order to convert into the carboxylic acid, what you need to do? You need to put OH. That means whatever the R is there, I need to remove this R. That means I need to break the bond between the carbon and I need to insert the OH. In order to break the bond between the carbon and carbon, it needs a lot of energy. Okay, so that's why it is not that easy. So see here, oxidation of secondary alcohol usually stops at the ketone stage because further oxidation requires breaking of carbon and carbon bond. That is a very drastic condition. So it requires more energy. It's not so easy to break the bond. So is it like impossible to convert the ketones to carboxylic acid? No, it is possible. There is other way. Okay. But using this strong oxidizing agent, it is not possible. We should need to use some other thing. Okay. So what is that? So ketones are oxidized with a difficulty. They are oxidized only on eating with the strong oxidizing agent. Okay. So you take the ketone. So there's a ketone. So now this ketone in presence of KMnO4, which is a strong oxidizing agent. Apart from using the strong oxidizing agent, you need to provide the acidic medium. You need to provide the eating as well. So then only it can break down into the smallest carboxylic acids. You can directly write it, but I'm just showing you to not to confuse you. Okay. So see here, what happened here? So there is a bond has broken. So here the bond has broken and carbon has left and OH is attached. Or you can simply say the bond has broken here and for this carbon, the OH is attached. Okay. And whatever this segment is there, that is this. So remember this. Okay. So what happened here? The ketones are oxidized with difficulty. They are oxidized only on eating under the strong oxidizing agent. So this is a strong oxidizing agent. So cleavage of carbon-carbon bond takes place and a mixture of carboxylic acids are formed. So you can see here, this is one type of carboxylic acid. This is another type of carboxylic acid. Here only one carbon is present. Here three carbons were present. So you can call this as propanoic acid. You can call this as methanoic acid. Okay. So because there's only actually this okay. So actually this is ethanoic acid and this is a propanoic acid. So here there are three carbons are present. Here two carbons are present. So as it is three, we called it as propanoic acid. As it is two, we call it as ethanoic acid. And this is the ketone which is having carbon, 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 and carbon. So total five carbons are there. Is it clear? Any doubts?
Yes, sir. No, sir.
Okay. So next one. So cyclohexanol is oxidized to adipic acid using a potassium permanganate in acidic medium. So this is another example where we can convert it. For suppose you take this cyclohexanone. That means it's a ketone, but it's an aromatic compound. So if you see here, this is carbon, 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 carbon. So carbon, carbon, carbon attached with a double bond O. So this is nothing but RC double bond O R, which is ketone, but it is a cyclohexanone. It is oxidized with the presence of potassium permanganate, that is KMnO4, and in presence of acidic medium. Whenever it is acidic medium, we should show a H plus. And not only that, what we need to do more? Need to supply the heat. Then only the breakage can happen between the R and R. If you don't supply H plus and heating, then it cannot break the R and R. So even though if you use the strong oxidizing agent, you should provide the proton, that is, you should provide the acidic medium and you should provide the heating. Then only the bond between the R and R can break. And this finally will turn out to be adipic acid. So draw the structure. This is adipic acid. So carbon, double bond O, OH, which is a carboxylic acid group, and this will attach to 4 carbons. And again, there is a carboxylic acid will form here. So this kind of arrangement is nothing but adipic acid. You can simply remember on this end, there is a carboxylic acid. On this end, there is a carboxylic acid. Intermediate 4 carbons were present. So see here, COOH. This is also COOH. And between, there are 4 carbons were joined, which is making the adipic acid. Understood? Understood?
Yes, sir.
Yes, sir.
Okay, Nitya understood. Mandara understood. Is it Mandara who said yes? Or Sharon?
Both, I guess.
Shrikar, you didn't get it?
Sir, kind of got it.
ఎరా మరి బొట్టిపై చెప్పాలేంట్రా చెప్పని
నాకే సార్ రెస్పాండ్
మధ్యలో జాయిన్ అవుతే ఇలానే ఉంటుంది. సో నెక్స్ట్ వన్, ఆక్సిడేషన్ ఆఫ్ ఆల్కహాల్స్. సో వాచ్ ద రికార్డింగ్ లేటర్. So what is this oxidation process? So when the vapors of primary or secondary alcohols are passed over heated copper at 573 kelvins, 300 degrees Celsius, the process is called as the dehydrogenation. Okay, this result in formation of aldehyde or ketone. So suppose you see here, there is a CH3, CH2, CH2OH. You are eating this under copper, which is overheated. So you will be taking a copper, you will eat that copper. So let's heat the copper. So what it will happen? It will oxidize. Okay, so it will oxidize and result in formation of either aldehyde or ketone. But it depends on whether it is a primary or secondary alcohol. So we studied already. So primary alcohols will oxidize and it will give which compound? Mandara, you say this answer. So primary alcohols, if we eat, it will give which compound? Mandara,
Sir?
are you there in the class?
Yes, sir.
So tell me, the primary alcohols, when they, in the previous, I told you, right? The primary alcohols, when you use some mild oxidizing agent, it will turn out to be something, either aldehyde or ketone. What is the answer?
So is it like aldehydes?
Yes. Don't forget the primary alcohols, they will turn out to be aldehydes. And secondary alcohols, they will oxidize to the ketones. Understood? So remember, whenever you oxidize the primary alcohol, it will turn out to be aldehyde. If you oxidize the secondary alcohol, it will turn out to be the ketone. So from this, what it will turn out to be? An aldehyde or ketone? So this will give what? An aldehyde or ketone? Mandara.
Yes, sir.
So what this will give?
Aldehydes?
Yes. CH3, CH2, C double bond OH. So remember CHO, we called it as the aldehydes. So this is an aldehyde. You can see here the C double bond OH, which is an aldehyde. The same, if you use the secondary one, CH3, CH, CH3. So the carbon is attached to two different carbons. So we call this as secondary alcohol. Okay. So remember, this is a primary alcohol and this is a secondary alcohol. So now this secondary alcohol, you do the same treatment. You treat with a copper ete or heated copper. So this will be giving CH3. Sharon, tell me what it will give.
Ketones.
Tell me the structure of ketone.
CH3.
Hmm.
C.
Hmm.
CH3, CH3, C. I mean, oxygen with H.
What is ketone? R, C, R dash. So a carbon is joining two different alkyl groups, and this carbon is containing the double bond O, carbonyl group. So that is ketone. So here there is a double bond O. Come on, guys, this is very basic. You will be studying in class 11th, all these things. See here, aldehyde is CHO and RC double bond OR, that is a ketone. Don't confuse. Okay. So see here, ROH, alcohol. R C double bond O R dash, ketone. R C double bond O H, aldehyde. R C double bond O OH, carboxylic acid. So don't confuse all these things. These are very basic things. So understood so far? What is the oxidation process? What will happen when you eat at 573 Kelvin or 300 degrees Celsius? The copper, and what happens to the primary alcohol and what happens to the secondary alcohol? So how does the primary alcohol will turn out to be? How does the secondary alcohol will turn out to be? So remember this. So the primary alcohol will turn out to be an aldehyde and the secondary alcohol will turn out to be the ketone. So here in the exam, they can give any structure. They can give a, here we are using the propanol. They can give the methanol. They can give the ethanol, but you can convert this into an aldehyde if it is a primary alcohol. If it is secondary alcohol, you will be converting into a ketone. Just remember that. So whatever kind of number of carbons they give, it doesn't depend. It depends on, so what is this kind of alcohol, whether it's a primary or secondary. Okay. And what catalyst are using? Strong catalyst or weak catalyst or mild catalyst? Are you supplying the heat or not? So all these things you need to notice. So next one, oxidation of alcohols. So far we studied about the primary oxidation, secondary oxidation. So what happens to the tertiary alcohols? Okay, so tertiary alcohols will undergo dehydration to give the alkenes. So that means, for suppose you take a carbon which is a tertiary, that means it is attached to three different carbons. So let's say this is our CS3, this is another carbon CS3, this is another carbon CS3. Now the other one is OH. So this is what? Tertiary alcohol. Now this tertiary alcohol, you treat with a copper at 573 Kelvin. Whatever the thing you did here, you do the same thing for the tertiary alcohol. At 573 Kelvin copper, you eat it. So this will give alkane. So the hydrogens it will lose and it will form the double bond. So remember, so whenever there is a double bond is present, it will turn out to be an alkane. Okay, so alcohol, it turned out to be an alkene. Understood? So what happens with the tertiary alcohols? So let's summarize all these things. So see here, if you take the primary alcohol, secondary alcohol, tertiary alcohol. So primary alcohol, secondary alcohol, tertiary alcohol, and a PCC, which is a mild or weak oxidizing agent, or CrO3, which is a weak oxidizing agent. The primary alcohol will turn out to be the aldehyde. The secondary alcohol will turn out to be ketone. The tertiary alcohol, there is nothing, we didn't talk anything because they don't show any reaction. If you use the strong oxidizing agent, it will turn out to be the carboxylic acid, the primary alcohol. It will turn out to be secondary alcohol will turn out to be ketones. But if you eat this, then it will turn out to be the carboxylic acid. Yes or no? The secondary alcohol just treat with a strong oxidizing agent. It will only show the ketone. But you do this further with presence of some acid and base and supply some amount of heat, then it will turn out to be the ketone. And tertiary alcohol, they are not oxidizing. Some will show the dehydration if you perform the same reaction with the copper at 573 kelvins. The same tertiary alcohol in presence of copper at 573 Kelvin, it will undergo the alkene formation. Remember this thing. But it will not oxidize it here. So you can see here, the primary alcohol KMnO4, and you supply the acidic medium, you supply the heat, then it will turn out to be carboxylic acid. Secondary alcohols will also show the carboxylic acid. Tertiary alcohols will not show. But if you use the copper heat, the primary alcohol will show the aldehyde, secondary alcohol will show the ketones, the tertiary alcohol will show the alkenes. Is it clear? See here, if you understand, all this will become very easy. You can easily remember. But if you try to mug up without understanding anything, you need to remember almost some mix of 12 kinds of reactions. That means the primary alcohol with PCC, the primary alcohol with CrO3, secondary alcohol with PCC, secondary alcohol with CrO3, tertiary alcohol with PCC, CrO3. So see, there is number of reactions will come on this way. But if you understand the concept, this will become very easy. Understood? So in the exam, they will not show like oxidizing agent. They will not tell like this. They will simply give some alcohol. And by that alcohol, you should able to identify whether it's a primary or secondary. For suppose they give like this, CS3, CS2, CS2, and CS3, OH. And they will put some arrow and they will show like some CrO3. Or they will show some eating, or they will mention it like upon eating in presence of KMnO4. They will say like that. So what will be the product? A. Upon doing something else. So like you supply some eating here. So there will be B. So what is A and B? They will ask like this. So from this you can say, so if you treat with a CrO3, what it will come? It will come the ketone. But the same ketone, if you treat with a proton and you supply the heat, it will turn out to be carboxylic acid, as we saw here. Okay, so it will form the ketone and the ketone will further turn out to be the carboxylic acid. So what is A and what is B? Simple. It is some 3 marks or 2 marks. But if you just by heart this, you will not able to answer this question at all. Because chemistry will be having L of reactions. How many reactions you will just mug up without understanding? Is it clear? Tell me honestly, who understood all these reactions so far?
Sir, I understood.
Understood.
Sir, I understood.
Understood, sir.
What about you, Shrikar?
Sir, I said I understood.
Okay.
Only a little bit confusion because I didn't hear the starting part.
Because the basic thing I told at the early that you missed.
Yes,
Okay.
sir.
You can watch in the recording.
Okay,
I'll
sir.
upload it in YouTube.
Okay, sir.
Okay. So now tell me here. So what will happen here? Tell me, what will be the major product? So this looks somewhat very big, but it is a very easy one. So tell me, what will be the answer? What are the things that you can see? Just forget what is the structure is there, this big structures. Just only concentrate on hydroxyl groups. And what kind of hydroxyl groups are they? Primary or secondary? And if we use the PCC, what the primary will turn out to be, what the secondary will turn out to be. Okay, I'll give, this will be answered by the Nitya, Sharon, Mandara. So tell me.
So this 1 degree alcohol and it'll turn into aldehyde because it's an
Okay,
oxidizing
Nitya,
agent
answer
PCC.
is aldehyde. Okay. What about you, Sharon and Mandara? What are your answers? Sharon, your answer is somewhat a little tricky, but try. Mandara, yours is very easy.
Yes, sir. So
What
it
is
would be
there? Come on, tell me. Yeah.
2 degree alcohol, so it would be ketone.
So this will be the ketone. Sharon, you tell me. So first you tell me whether it's a primary, secondary, or tertiary.
Tertiary.
It is a tertiary. So what happens to the tertiary?
Alkene.
Huh? What are the catalysts are we using? Are we using any copper here to say alkene dehydration is happened?
No, sir.
What happens for the tertiary when we use react with a PCC, which is a mild oxidizing agent? Huh? So what happened here? See,
Oxidize.
yeah, it will not oxidize. Okay, so no oxidation will happen. So the structure, the final structure will look like this. Okay, so when you do the PCC, I'll try to draw this structure again. So what is this? This is a primary carbon that is attached to OH. So we know the primary alcohol will turn out to be aldehyde. Secondary alcohol will turn out to be ketone. Tertiary alcohol, if you use the PCC, mild catalyzing agent, sorry, oxidizing agent, it will not show any reaction. So no reaction. So from that, I can say, I can show the reaction will happen like this. So this carbon should show the aldehyde. That means the carbon should contain the double bond O and it should contain the hydrogen. So this became, so this thing became the aldehyde because CHO, or you can say C double bond OH, which is nothing but the aldehyde. Now come to this. So this carbon, so this is a primary carbon. So this carbon is a secondary carbon. So the secondary carbon will show this way. It should form the ketone. So simply ketone is nothing but R, C, double bond O, R dash. So if you see here, this is one R, this is one R, or you can say this is one carbon, this is one carbon, and this is the main carbon C, which is having the double bond O. So that's it. This is the ketone. And what else? What about this? This is the tertiary. The tertiary doesn't show any reaction. Tertiary doesn't show any reaction. So I'll keep the OH the same. That's it. This is a PYQ, NEET one question. Okay. I think NEET or JE, it came in JE or NEET. Okay. So very simple. Understood? But seeing this structure, we feel like it's very hard. So always remember, the alkene and tertiary alcohols will not react the PCC. That means if you see the double bond, they will not be affected. I told you at the beginning. So double bond will not be affected. using the strong oxidizing agent. I mean, using the oxidizing agent, it's a PCC, the mild. So PCC will not show any reaction to the double bond. You can call this as the alkene. And they will not show for the tertiary alcohol as well. But for the primary, secondary, and they will be showing the primary alcohol in presence of the mild, it will turn out to be aldehyde. If it is a strong oxidizing agent like KMNO4, it will turn out to be the carboxylic acid. If it is secondary alcohol, this will turn out to be the ketone. Even if I use the strong KMNO4, still it will be ketone. So that's how the reaction will change. Instead of keeping the PCC, if I keep the KMNO4, you will be getting the different answer. Understood? And if I use the copper reading, it will be showing the different answer. So next one. So tell me, what is the answer for this?
Second. B.
Yeah, the answer is B. So primary alcohols on oxidation, they give what they will give?
Aldehyde.
Yeah, primary alcohol, they will give the aldehyde. Secondary alcohol, they will give the
Okay.
ketone. Tertiary alcohol. So oxidation of tertiary alcohol will happen. I mean, use any catalyst, whatever the catalyst. The tertiary alcohol, if they get the oxidation, they will turn out to be the alkene. We saw that dehydration will happen. Okay. So what is the answer here? The secondary alcohols. So that's it. So next one, the reactions of the phenols. So phenol shows the different reactions. We'll not be studying all this today, but we'll see. So it will show the oxidation, electrophilic aromatic substitution, Colby reaction, Raymer-Thiemann reaction, very, very important for the board exam, Colby reaction as well, and the reaction of phenol with a zinc test. See, named reactions, you should remember, they are very, very important. So let's see, what is this oxidation of phenol? So phenol is oxidized to benzoquinone using the sodium dichromate, Na2Cr2O7, in the presence of sulfuric acid and water. For suppose, let's take the reaction. So what is phenol? It's nothing but the benzene ring attached with OH. So this is a phenol. So let me write the structure. So this is a benzene ring with OH. So we call it as phenol. So this phenol in presence of Na2Cr2O7. So what is it called? The sodium dichromate. And in the presence of sulfuric acid, H2SO4, and in the presence of water. So when they are having all these three, it will be giving the benzoquinone. So what is benzoquinone? It is nothing but a benzene ring which is having two ketone groups. So that is called as benzoquinone. Always remember, whenever you use the word NONG, it is nothing but the ketone. It is a ketone. So this is benzoquinone. Okay. So how do you characterize this benzoquinone? It is having two carbonyl groups. So you see here, there is one carbonyl group is present here, C double bond O, and there is another carbonyl group is present. If this carbonyl group, C double bond O, is attached to two different carbons, then we call this as a ketone. If the same carbonyl group on one side attached to carbon, on the other side attached to OH, it is a carboxylic acid. If it is attached to the hydrogen, it is the aldehyde. Okay. So that's how one compound will be changed to different carbon when you change the things here, the atoms here. Okay. So remember this. So how do you define this benzoquinone? This is called benzoquinone, known as it is a ketone, alcohol, phenol. Okay. So what is phenol? It's nothing but the benzene ring with OH group, and benzoquinone It's nothing but two carbonyl groups attached to the benzene ring. Okay, so you can say two carbonyl groups attached to benzene ring. So it is called as the benzoquinone. Okay, so this is what happens if you use Na2Cr2O7, sulfuric acid, water. This benzene will convert into the benzoquinone. So next one, electrophilic aromatic substitution. So what is meaning of aromatic? It's nothing but a closed chain aromatic compound. We are having two things. One is aliphatic, aromatic. Aromatic means the closed chain. Aliphatic means the open chain. So there is a aromatic compound. There's a closed chain which is having the electrophilic substitution. For suppose you see here, let's take the benzene, which is the best aromatic compound. So this benzene ring, you give some electrophile. Okay. So that electrophile, what it will do, whatever the carbon that is there, if you see the structure, here the carbon is attached to another carbon and attached to another carbon. So there are three, and it is also attached to hydrogen. So this is how the benzene ring looks. Let me draw full structure. So there's an alternative double bonds are present. So just put the hydrogens here. Hydrogen, 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 hydrogen. And there is a hydrogen here. Okay. So now what this electrophile will do, it will replace this hydrogen with that electrophile. Okay. That is what electrophilic aromatic substitution means. Okay. So what happens here? That will replace the electrophile with a hydrogen. So that is called as electrophilic aromatic substitution. Understood? So how does the electrophilic aromatic substitution will happen? So there are hydrogens present on the carbon in the benzene ring. So that carbon will leave that hydrogen and it will attach to the electrophile. Okay. So in electrophilic aromatic substitution, so what happens to the OH group? That means if there is any OH group is attached, so what happens to that OH group? First of all, it will show a powerful activating group due to the mesomeric effect. I told you what are these positive mesomeric effect, negative mesomeric effect. I'm not getting into detail now. So what it will do, it will show the positive mesomeric effect. Okay. So because of this positive mesomeric effect, what happens to the benzene ring? There will be increase in the electron density on benzene ring. Just remember this. Okay. So due to this powerful activating group, that is the OH group, it will show the positive mesomeric effect. That means it will contribute the electrons to the benzene ring. So now this benzene ring will be having too many of electrons. So the electron density will increase on the benzene ring. And what happens? What is the other thing? Ortho para director. That means whatever the compound that is coming, whatever the molecule or atom that is coming and attached to this three positions. What are the three positions? Para, meta, ortho. Is it that or OMP? OMP. Ortho, meta, and para. So what happens here? It will direct towards the ortho and para. That means whatever the compound that will come and attach here on the ortho or meta or para, they will mostly sit on the ortho or para position. They will not sit in the meta position. That you need to remember here. Okay. So what happens here? Just remember this. It is nothing but whatever the incoming electrophiles are there. So those incoming electrophiles, they will sit in the ortho or para positions. So that's what an ortho para directors mean. Okay. So let's see an example here. First, suppose let's take a phenol that reacts with a dilute nitric acid. So take a phenol. With OH in presence of dilute nitric acid. Nitric acid is nothing but HNO3. Okay, so at 25 degrees Celsius, it will form the benzene ring. Okay, but whatever the from the nitric acid, you will be getting the NO2. So remember, from this nitric acid, you will be getting the nitrogen dioxide. So this NO2, either it will sit in the para position or meta position. So let's keep the OH, but this NO2, either it will sit in the para position or it will sit in the this position. Okay, so but which one will be the major product and which one will be the minor product? So this one will be the major product and this one will be the minor product. Why? See, if you see here, the whatever the 100% is there, they are not forming the 100%. So it's a not a complete reaction because they cannot form completely these compounds. Okay, they will only form to some extent. So that's why it's 30 to 40% and this is a 15%. And if you see, the probability of attacking at the ortho position is more than a para because the double number of the ortho position in the benzene ring. So what is ortho meta para? So this is OMP. So if you see here, ortho, either I can put the ortho here or I can put the ortho here. I can put the meta here, I can put the meta here. But para, it's only one place, that is here. If I take this way, it is here. If I take this way, it is here. So the para is only having one position, whereas ortho, it is having two different positions. So that's why the probability to attack the ortho position is more than para. Para is only having the probability one. Ortho is having the probability two. So it is more. So double the number of ortho positions. Okay. So that's why the ortho will form more concentration compared to the para position. Understood this? So why ortho is more compared to para? Whenever if you see something between the ortho and para, you always see the major will be the ortho compared to the para because of availability of two positions, whereas para availability of only one position. And if you see OMP, always ortho and para are the good positions. Meta, only few compounds will settle, but least meta is the least reactive. These things you need to remember because whenever the question something like this comes, you don't know what will be the answer. You can write something this way. Okay. So see here, HNO3, that means it gives the NO2. Now I need to put the NO2 somewhere. So I can put here or here or here. So I'll put here and I'll put here. But this will be the major concentration. This will be the minor concentration. So I can put this as a major product and this as a minor product. That you need to remember. So see here, yield is relatively low because of oxidation of the ring. So you can see here, that's why it is not produced the full yield. It's only the less yield. Ortho and para isomers can be separated by steam distillation. That means you got mixture of two compounds. We need to separate them. So that we can be done by the steam distillation. That means you will be boiling and you will be extracting them in two different points. So what is the benefits of ortho and para positions? So ortho position, it's an intramolecular hydrogen binding. I'll show you what is this. Para position, it is intermolecular. Ortho position is more volatile. Para position is less volatile. Ortho position passes over with the stream. Para position, it will still remain back in the distillation. That means it will not be completely purified. So some will be left over in the flask itself. But here, complete boiling will happen. So there will be nothing of orthonitrophenol will just left over after heating in the flask. So all will be evaporated. So that you need to remember here. So what is this intramolecular binding and intermolecular binding? You can see here. So orthonitrophenol, which is intra, that means you can see here within the molecule, the binding has happened, hydrogen bonding has happened. So that's why it is called as intramolecular within the molecular. If you see here, this is intermolecular. That means between the two molecules, as we studied, intracellular, intercellular. The same way here, intra means within. So this is within and this is between two molecules. So remember that. Okay. Only 3 slides left. So just remember. So phenol with concentration nitric acid gives the picric acid. Okay, in a low yield. That means it will not be completely formed. You will be getting some less amount of this picric acid. For suppose you take the phenol. So what is phenol? It's nothing but the benzene ring with a OH group. So now this benzene ring with the OH group, you treat with a nitric acid, concentrated nitric acid. So with this concentrated nitric acid, or you should also treat with a concentrated sulfuric acid. Remember, it can be the concentrated nitric acid or sulfuric acid. It will be giving if it is nitric acid, it will be giving NO2. If it is sulfuric acid, it will be giving SO2. So I can attach the OH will be here. So now I can put NO2, NO2, NO2. Arrange as much possible as far distance so that they will not show repulsions here. So the same molecules will not show any repulsion. So I kept them in a distanced way. So I have a, and that is one reason. Second reason is O and P. Ortho will be having more probability. So it will attach both the ortho positions and there will be para position. Okay. So this compound is called as picric acid. So what is this picric acid? It's nothing but there is a nitrogen groups, nitrogen dioxides, which are present on both the ortho positions and para positions. And there is a phenol. So that's called as picric acid. You can remember like that. So just take a phenol, OH, and put the nitrogen dioxides and O2s on these positions. So that will become the picric acid. Okay. So remember. And one more thing you need to remember here. So this picric acid is a highly exothermic reaction. So what is meaning of exothermic reaction? We have two types of reactions. Either you are giving the energy or after the reaction, the energy is produced. If you are giving the energy or the energy is released after the reaction. So based on that, exothermic or endothermic. If a lot of amount of energy that is released, then we call it as the exothermic. Exo, remember exo means exit. Remember it is an exit. That means lot of energy released. So that's called as the exothermic reaction. Endo. Endo means remember. Endo means in. That means you need to supply lot of energy. Supply energy. So it is called as endothermic. Release energy, exit. It is called as exothermic reaction. Understood? So what happened here? The phenol you treat with a nitric acid, it will give the picric acid and it will liberate a lot of energy. So that's why it is called as the exothermic reaction. So next one. I told you here, if you see here, it will give only the low yield. So is there any other way that I can produce more this picric acid? So that's the question. So is there any other convenient way for producing the picric acid? For suppose you take the phenol, phenol. I told you I can use either sulfuric acid or nitric acid. So what happens if I use the sulfuric acid? So you treat the sulfuric acid. So then what happened? There will be SO3H will attach. So it will attach here and here. And now the same reaction you treat with nitric acid, HNO3. So this nitric acid will replace all the SO3H and it will attach here NO2, NO2, NO2. So very simple and easy way. So you take the phenol, you treat with the sulfuric acid, it will attach on the para and ortho positions. So SO3H, SO3H, because this will give like H plus HSO4 minus. Okay. And you remove the water molecule from this. So, or you remove oxygen from this, that will turn out to be HSO3. and O. Or you can remove like a hydroxyl. So now we are not getting into detail. So just remove the hydroxyl group from HSO3, HSO, H2SO4. You will be getting SO3H. So H2SO4, it will give HSO3 and OH minus. Okay. So that will give HNO3 and treat with HNO3. You will all the SO3H will be replaced with NO2. Okay. So what is this? This is nothing but a phenol. So this is a phenol. And what is this? If you see here, there is a sulfonic acid was attached. So we can call this as phenol 2, 4 because this is the second and fourth position. So 2, 4 disulfonic acid. And what about this? This is nothing but picric acid. Picric acid where NO2s are present, nitro groups were present. What are they? These are called as the nitro groups. Okay, or nitrogen dioxide. So this nitrogen dioxide attached on what positions? So let's say this is 1, 2, 3, 4, 5, 6. So they are attached on the second position. So 2. They are attached on the 4. They are attached on the 6. So 2, 4, 6. How many nitrogen groups are present? 3. So 2, 4, 6 try nitrophenol, which is nothing but our picric acid. Okay. So this is another way where you can synthesize. So what is the first step? You need to treat the phenol with a concentrated sulfuric acid. That will result in the formation of phenol 2, 4 disulfonic acid. Now you treat this again with a nitric acid. Okay, so that will be giving the nitro groups which will be attached on the ortho and para positions relative to the hydroxyl group. So we are saying this is para and meta and ortho positions with respect to hydroxyl groups. So that is how the picric acid in other way it is formed. Okay. And the final slide. So picric acid, what is the use? So it is a yellow color. So it can be used as a dye for the silk material, can be used to make the explosives, can be acid strengthening of the picric acid is more than the carboxylic acid. That means you give the picric acid, it will contribute for the acid making. Okay. So picric, picrose, the bitter word. So that's it. Any doubts?